Hey everybody, this is Alex Merced from alexmercedcoder.com, and in today's episode what I want to do is talk about TypeScript to just be this sort of a introduction to TypeScript if you've never used TypeScript. So think of this as a TypeScript for noobs. Okay, so bottom line is, what is TypeScript first? So TypeScript is a superset of JavaScript. Now what does that mean? A superset of JavaScript just means, if you think this is JavaScript, then TypeScript is something that includes JavaScript but has more than JavaScript. So it's a superset language. It has everything that you're used to in JavaScript. So if you know JavaScript, you know the vast majority of TypeScript with extra features. Primarily, the extra features that are in TypeScript revolve around the idea of typing. And typing is the idea that you can identify what type of data should be stored in variables, should go into functions as arguments, should be returned by functions. And the reason this is important is because, one, bug hunting, because then the IDE is aware, your editor is aware of what you intend to put inside functions or get back from functions. So it can catch errors and let you know about them more easily versus and if you didn't type. 2, compile time errors. So TypeScript is a compiled language. It gets transpiled into JavaScript. So when you run the TypeScript compiler, it reads your TypeScript code and then converts it into JavaScript, because again, the front end only knows how to read JavaScript. So it converts it to JavaScript and then reads it, or the browser can then run it. So the benefit is that if there's any types of type errors in your code, if you didn't catch them because your editor didn't tell you about them, when it compiles, you'll have a compile time error. And that also gives you an ability to make sure that there isn't any mistakes in your code. And then 3, it makes it just your code more, when you're working on a team, and now I run into some code that uses some custom function that you created, what the intention of your function is a lot clearer, because the types can tell me, hey, you intended that these parameters are these things, that this function returns this thing, so I have a better and clearer idea of what your function should be. Okay, this becomes really useful when you're doing things like React, because then things like props get typed, so that way when you're using a component, you know exactly what the props should be, not just what they are, but what they should be, and that can be really, really helpful. Where it gets frustrating up front is that when you've been doing a lot of JavaScript, you're just kind of used to being able to just pass any kind of data you want to a function and get back any data you want from a function and not have to think about it, and it not being the source of errors. That does definitely take a second to get used to. Okay, but we're gonna get started, and what I recommend, if just for the sake of just being able to like play with TypeScript, I recommend using my Merced Spin-Up tool. So my Merced Spin-Up tool is a tool for spinning up project templates. I have templates for all sorts of different frameworks and all sorts of really good stuff. So definitely something worth playing around with. Okay, so check that out on NPM. So I'm gonna head over, and again, I'm going to assume you have Node installed. If you don't have Node installed, you should. If you don't have Node installed, that means you probably haven't done that much with JavaScript, which means you should probably spend some time learning JavaScript first. The way to do it is really kind of get comfortable with JavaScript, and then you graduate to TypeScript. Yeah, that would sort of be my recommendation. But assuming you have some familiarity with JavaScript and comfort with JavaScript, and you'd like to try out TypeScript, here you go. So what I want you to do is we're gonna open up, I have this new folder, just TS or TypeScript folder that I opened up in my editor, VS Visual Studio Code, and I'm opening up a terminal. And I'm going to use the Merced Spin-Up tool to create a new project. So Merced Spin-Up TS, this is for, meaning like TypeScript. This is my TypeScript template. TS, and we just say practice TS. And again, this template is really meant for practicing TypeScript. Oops, I forgot the NPX part. So it's NPX Merced Spin-Up TS practice TS. Okay, there we go. And see, we created this folder. So I'm going to CD into that folder. And then I'm going to run npm install, so that way it installs everything I need in that folder. Good. Now the way this works is, again, Node or the browser don't know how to read TypeScript. It's just they don't know what that is. So the way it works is that you write in these TS files, which are TypeScript files, and then the TypeScript compiler. Okay, so again, TypeScript is a dependency of this. So see, like TypeScript is a thing that is installed. Okay, and you can configure TypeScript through this tsconfig.json. Although here I have some pretty basic configurations to work with. But there's a whole world of different like compiler options and whatnot you can do to really customize what TypeScript does for you. Okay, but essentially the way this reads, the parts that really are important to you is that when you run the compiler, okay, and right now this is kind of built out for you, so you go to package.json, all you have to do is run the start script, and the start script will run the compiler, which will read the compiler config, which will then compile the code, and then it's going to run the compiled code that gets compiled into this compiled folder. Okay, so the way I have it configured right now is that it's going to compile these files. So if you wanted it to compile other files, you'd have to edit this, but right now it's always going to compile this index.ts, which means any files that it's connected to will get compiled as well. But it'll start there, compile that, and then whatever the output is will end up in this compiled folder. Okay, so that's how this works. Okay, and anytime you want to run your code, you just do npm run start. Cool, simple. So this looks a lot like JavaScript. So again, I could just like normal JavaScript, I can do console.log cheese. Okay, so again, nothing really kind of changes in JavaScript world. So I can do npm run start just so you can see what happens. See what it does, it compiles the code and then runs it. So see console log cheese. But you see, like, it didn't run this file, it ran this file, index.js. So this is the result of my compiled code. Okay, cool. So let's just show you some of the cool features in TypeScript. So for example, in TypeScript, I could declare a variable. So we'll say const cheese, but let's say I want cheese to be a string. I can say cheese, and then I use a colon, which designates that I am labeling what type of variable or what type of data point I want cheese to be. So I'll say string. Okay. And then I just say equals cheese. And see, it's not complaining because cheese is a string. But let's pretend that I put a number here. See, right there, it's already starting to complain. So I can say, wait a second, this doesn't seem right. And if I hover over it, should kind of give me a little warning as to why I'm getting this problem. Okay. Wow. I don't know. I think I have so many extensions installed that that'll like really just kind of hover over and see the error is getting a little bit. But just to make it clear, let me just run npm run start and just get the error during compile time. So npm run start, and see I get a compile error. And if I read the error, what does it say? Type number is not assignable to type string, because 1 is a number, not a string. So see, I declared my intention, and the editor was able to prevent me from making a mistake. That's really cool. Okay. Now the problem is, what if I want this variable to be, you know, a 1 or a string? Okay, I can do that. If I remember right, I should be able to just do like or number and do that. Or I think it's actually just one pipe. Yeah, just one pipe. Okay, and see that means string or number. Okay, and so this is fine. But what if I try to make it a Boolean? Once again, I'm going to get an error because it's like, wait, that's not a string or a number. Okay, now if I just get really frustrated and I can't just figure out how to type this thing, they do give you an escape valve. I could always just do any, and any just means anything. You want to avoid that, because if you use any too much, then what's going to happen is you're not going to really get the benefit of it or the assistance. Now, where this really gets helpful is you can actually like create your own types. Okay, so instead of having to type in type, number or string all the time, I can just say type, okay, number or string. So I'll just do ns, type ns equals, okay, number or string. Okay, so now what I can do is I can say const cheese again, const cheese ns equals 1. And see, that's fine because ns can be a number or a string. Once again, if I do it a Boolean, it's going to complain. It's going to be like, hey, that doesn't follow the type. So if I go again, run the code, I get the compile error. See, it says Boolean is not assignable to type ns. It's like that type doesn't include a Boolean. Okay, so you can, that's pretty neat. Okay. Now, second thing, I can actually define the shape of objects. Okay. So and this is by doing what's called an interface. So let's say I want to have an interface for objects of type person. Okay, so I want to say, hey, a person is always a name, okay, which is going to be a string, and an age, which is always going to be a number. Okay, I forget if I do the colons for an interface. Maybe I don't. No. Oh, I know why. You don't need an equals here. I'm not assigning, it's not a variable. I'm declaring that there's this, kind of like you declare a class, I'm declaring that there's an interface called person, and this is the description of person. Okay, so now, if I were to create an object, so I say const Alex is a person, okay, now I can say name Alex Merced, age, and actually I forgot the equal sign, age 36, and see, now it's happy. But what if I said suddenly I want to add an email? Okay, so we'll just say dev@alexmerced.dev. Okay, it's like, wait a second, this is not a thing, like this doesn't exist in, so if I run, if I run the compiler, okay, I get this error. It's just saying, hey, type this. So it's saying, hey, the thing that you gave me is not a person. Like, that's not the way you describe a person. Okay, what I can do is I can add email. Okay, and I can add a question mark at the end, if I remember correctly. And again, I can say this is a string. And the question mark just means that it's optional. So now if I, so this, see, it's not complaining now. And if I take off the email, it doesn't complain because it's not required to be there. Okay, the question mark just means like, okay, email is optional. And then if I take this off, though, it will complain because it is expecting the age property. Okay, so that's what interfaces are for. They allow us to kind of describe objects. Okay, so we learned that we can declare our own types, and we can declare our interfaces, and we can type our variables. Let's just keep going. Okay. Also, when I declare my types, I can define, like, I can type arrays. So let's say type array of strings. So string R. Okay, then what I can do is says equals an array, and then here I say like what the type of things in the array are, so string. So this means that whenever I say that the type is this, it has to be an array, and the things inside the array have to be a string. So if I do const R equals, and then let's type that, string R, I put in cheese, so far so good. I put in the number 5, and now it complains. And so you see a little red squiggly line, it doesn't like it. Why? Because string R is supposed to be an array of strings. Okay, now I could change this. Other ways you can type arrays, like if you want to be very specific, where an array can only have a certain number of items of certain types in a certain order, you can get that specific. You can just be like, string R has to be an array of a string, then a number. Not string or number, has to be a string, then a number. So right now it's fine, but let's say I do it the other way around. 5, then cheese. It still throws me an error because it's not a string, then a number. So you can create very, very specific types, okay? And this can become really useful because what if you have a function that needs, the first argument has to be an array, that's a string, then a number. Okay, so I can say const, make person. Okay, and then I'm going to say, and then what we do is we type you say equals. Okay, and I think you can type this as a function. So this is a function. I think function is a type. There we go. Type function. Okay, and then here's where we would type the return value after the parentheses. So we're going to say it's supposed to return a person. So let me go back and define that person interface again. Okay. So interface person. So there is extra typing. You do have to like type all these like interfaces and types out, and sometimes you have some really complex functions that can have a large variety of arguments. So getting all that typed up correctly can be really tricky. That's where things get fun. But interface person, again, name, which is a string, and age, which is a number. And there's our interface. Okay, so our function is supposed to return a person, and see, it's complaining because right now, the way the code's written, it does not return a person. And then I'm expecting that there's one argument called the data, which is of type string R. Okay. And then what I say is we're going to return, okay, an object with a name property. And the name property is going to be data 0, which is going to be okay with in a second because, again, technically the first item in this array should be a string and name should be a string, so that it'll realize that that's okay. Age, which should be data 1. And see, now it's happy, because it knows that this has to be a string, or else it's going to throw me an error if this is going to get something other than a string. So it all has to kind of match up. Okay, so now, so you make sure that when I write the function, that my function matches the types. And now when I use the function, so if I say make person, now watch what happens. I go make person, and well, usually it would give me like little hints. Make person, and then we're putting in, it's not giving me as many type hints today as usual, but usually it would tell you like, oh, it needs an array of a string and a number. So in this case, we'll say Alex Merced, and then I hit comma, and then we'll put 36. Okay, so now let me run this code, and let's just take a look at what the JavaScript on the other side turns into. Okay. And see, this is the JavaScript that it turns into. Okay, which is fine, because theoretically, like, even though, like, now this is JavaScript, so technically, like, if this array gets generated dynamically by, like, let's say my backend server based on API calls, it won't be able to check the data coming in from an API call. The idea is that at least, like, in my source code, everything matches up with my intention. Okay? And, again, I can't control for what data comes out from, like, other sources, but at least I have, like, this is all internally consistent. Okay? And I technically didn't do anything with that make person, so let's console log make person so we can see that it works and everything works hunky-dory. Okay, so I'll run that. It compiles the code again, and see I get Alex Merced, which is a string, and age, which is a number. So that's the benefit of TypeScript. Okay, and again, as you can see, that like not only did it help me, these types helped me like make sure that my function does what I expected it to do, because I expect it to take in a certain kind of data and come out with a certain kind of response. And it's going to make sure that my code does that. Okay, if I tell it, hey, this is what my function is supposed to take in and take out, and the internal details of the function don't do that, or my calls to the function don't do that, it's going to complain. Okay, and that's kind of nice. That definitely saves me, minutes of head scratching. Okay, so the more you type, the more suggestions it can make. So it does. There's again a little bit more work in making sure you get all those types, but this is all good. Okay, and you can import the types. The types are data that you can import into another. So for example, I could take these two types and cut them out of here and put them. Usually, what I like to do is I like to have a types.ts file, and I'll put all my types in here. So I'll have these types, and then what I'll do is I'll export each type. So we'll just do a normal export of that, except I need to spell export correctly. Okay. Export. Okay, now index.ts. Now it's complaining because those types aren't defined. So now I got to import them. So I'll import string r and person, and that's going to be from /types. And see, now my code's all good again. Okay, and then if I compile that, let's see what happens in compile. See, now it not only compiles index, but also compiles the files connected to index. See, it didn't compile my data because I didn't import data. So there was nothing. All it cares about is that index is the file that it starts with. It sees that there's this import statement, so then it's going to compile any files that are connected to it as well, and then I'll put them here. So you see here, if I go to types, okay, in this case, it doesn't really care because the types aren't something that is going to really be in JavaScript, so you get this sort of nothing. But here I get the relevant code. Okay, and then here, like, technically anything that should have been exported will be exported and it'll all be good. But again, the types are all going to be kind of stripped out because JavaScript doesn't have types, at least not at the moment. I mean, I don't think anyone would be surprised if they introduce types later in JavaScript. Okay, so this is just like the basic playground for playing with TypeScript. But another good template to use is the Vitae project generator. Vitae is this really cool bundler. Okay, so if you type in, so I'm going to go back up a folder, back to the TS folder. So if you type in npm init Vitae, what it's going to do is allow you to generate a project using Vitae, which is this really super fast, awesome bundler. And I'll type in, like, you know, TS project, and it gives you all these different options. Okay, and generally for each of these options, it'll give you a choice to use a TypeScript version. So you can do a project in Vue, React, Preact, let elements felt. I think for all of them, it offers you a TypeScript option. I'm going to choose vanilla. So I'm going to say, hey, I want to do vanilla JavaScript, meaning no framework. And see, it gives me an option between just normal JavaScript and TypeScript. So I can choose TypeScript. And what I can do now is I have my index file here, which is connected to this source code here. And I have my main.ts file. Okay, and then again, I can basically write front-end code here using TypeScript. And again, when I run, basically what you would do then is you would build it. So here's like the command to build it, and then that would build the final code. Okay, but you can again just do all that cool stuff. I also, if you really wanted to use jQuery with VS Code, I do have a template for that using Merced Spinup. So let me go back again. npx Merced Spinup. I think it's jQuery TS, and we'll just say jQuery JQTS. This is a folder. Yep, and see, there it is. And then this is just another one. This one's using Webpack. Again, the bundler doesn't matter, but the idea is, again, it's always in the source code. So here's your index file, and you can use jQuery to do things. Okay, and I also have Lodash installed, so that way you have all the benefits of Lodash functions, and Sass is set up, so you can use Sass. So it's a pretty nice template to do sort of advanced things if you wanted to try jQuery with TypeScript. Okay, because why not? Have fun with it. So those are some other templates available to you if you want to do like more stuff with TypeScript. But again, the benefit of just doing stuff in TypeScript is just you get the benefit of those IDE hints to make sure that like your code is following through with sort of your thought process. But my name is Alex Merced from alexmercedcoder.com. Hopefully this gave you a great way to get started with TypeScript. TypeScript has a plenty of more other features built into it, but essentially like, that's like the core of getting used to using it, is just being able to type things and know when you should type things and how to type things. But you can dive deeper with experimental features like decorators and other things which are super cool, super useful. But I'll leave it at that. Have a wonderful day and enjoy.